In question 4, we have A and B, two fixed pegs. A is 4 meters above B, so when we have our split triangles here, there'll be 2 meters in each. We'll call this angle A and this one B. And we have a radius, and we have M, so mg for the mass. Okay, we set up our tension diagrams. Let's have a look what's going on here. We've tension in the string up the top. It's going to be different than the one below. So we have angle A, we have tension in the string, we have T sine A, and we have T cos A. In the triangle below, we have the angle B, and we have a different tension, so I'm going to go back and call the first one T1, and call this one T2. We have the angle B, so we have T2 sine B, and we have T1 cos B, and that should be a 2, and that's going down, as is mg. So let's see, my force is going down. Looks like I have mg plus T2 cos B going to be equal to the forces in the other direction, which will be my T1 cos A for my vertical. And we're told that the tension in the upper string will be double the tension in the lower string. So tension in the upper double the tension in the lower. So T2 will be equal to T1. This question, we're going to need that in a minute, I'm sure. Right, let's have a look at in the horizontal. What have we got? We have these two in the horizontal, my T1 sine A and my T2 sine B. So T1 sine A plus T2 sine B is equal to my centripetal force. Is it W we're looking for? It is mW squared R. And we know that T1 is 2T2. And actually we also know that we have an R and a 2 in these. A is equal to B in this case. So let's change them all to A. So 2T2 sine A plus T2 sine A is equal to mW squared R. So 3T2 sine A is equal to omega squared R, and we're told we have the tan of A. We can get the tan of A in terms of R and 2. The tan of A is equal to O over A, so R over 2. So we can make this into tan A by dividing by cos A. And then maybe we'll be able to simplify and get cos A up here. That seems to be what will happen here, I think. So 3T2 by the tan of A. Tan A, I'll just do a little arrow so I'll save myself a line. The tan of A is R over 2 is equal to mW squared R over cos A. So I can divide by R now and tidy this up. So I'm going to come up to the space where I have some room up the top. I have 3T2 over 2 is equal to mW squared over cos A. So I need to tidy up for cos A here, and knowing that A is equal to B here, I'm going to have T2 cos A, T1 cos A minus T2 cos A is equal to mg. So we actually have I get mg over cos A. If I divide by cos A here, I get T1 minus T2 is equal to mg over cos A. And I have T2. I'll just write it down again from earlier. We had T1 was equal to 2T2. So I'm going to get 2T2 minus T2 is equal to mg over cos A. So T2 is equal to mg over cos A. Will that help? So cos A from here, cos A will be equal to mg over T2. And subbing that in here, that would mean you turn the fraction upside down and multiply. So we're going to get, just do it in a color we can see, we're going to get 3T2 on the left hand side here. We're going to get 3T2 over 2. I have it up here as well. 3T2 over 2 is equal to m w squared. And instead of dividing by cos A, I'm multiplying by T2 over mg. So my m's cancel and my T2's cancel. So I'm left with, if I multiply by 3g over 2 is equal to w squared. So w is equal to the square root of 3g over 2 radians per second.